Hello, ladies and gentlemen. In this short video, we're going to cover three things. Clarifying rule number 3, looking at significant figures in scientific notation, and quickly looking at multiplying and dividing. You have another resource that helps you with multiplying and dividing as well, so look at that one too. There's also a key for the back of your C notes that shows the correct sig figs for the examples that are printed there. So rule number 3, recall that rule number 3 says that zeros are significant if they're on the right of the number and there is a decimal point. So let's go through a couple of examples. This would be an example of a value with 3 significant figures. There are 2 zeros in this separated by a decimal point. The first 0 counts because of another rule, but the 0 that's on the far right counts because of rule number 3. So this has 3 significant figures. This value has 5 significant figures. All of those zeros that are on the right side of the number count. The leading 0 does not count, however. Then this value has 10 significant figures. And let's look at this 70 in a 2 significant figure form. So if we were sure to a reading of 70 with 2 significant figures, we would just write 70 with a decimal point. And if we were not as sure as 2 sig figs, then we would simply write it like this with no decimal point. And this indicates that we're only sure to the tens digit, and we're a bit unsure to this one. So this is 1 sig fig. So this list of values right here gives you a good feel for how to read sig figs when the number appears to be the same, but it's becoming increasingly precise because of the number of significant figures. Okay, let's take a minute to talk about scientific notation. So scientific notation follows a pattern where you have 1 digit before a decimal point followed by digits after that decimal point in most cases. Sometimes there can be nothing behind that decimal point. And then this value is raised to 10 to some power to determine where to move the decimal point back and forth to represent the number. So this value right here, 1.725, times 10 to the 4th, has a positive exponent. Then the one beneath it has a negative exponent. Here's another negative exponent. So let's look at what that means. This is a quick review. I think you know how to do this. When the exponent is positive, then that means we're going to move the decimal, and we have a base 10. When we have 10 raised to a power, and that power is positive, then that means we move the decimal point to the right to make the value larger. So in this case, we move a decimal point to the right 4 places to make this value larger. Then in the one beneath it, it's an example of when the exponent is negative in blue. So when we have 10 to the negative 2, that means that we move the decimal point back to the left to make the value smaller. So 8.06 times 10 to the negative 2 is equal to 0.0806. This value got smaller because we moved the decimal point toward the left. So look at these others if you need to kind of recall how that pattern works. Okay, it's really easy to find significant figures from scientific notation. You ignore the exponent altogether, and you simply count the digits that are in the leading value. So for this first one, there's 4 numbers here, so there are 4 sig figs in this value. The next one, there's 3 numbers here, so there's 3 sig figs in this value. This one has only a 4, so there's 1 sig fig here, even though this is raised to the power of it's 10 raised to the 6th power. So never pay attention to these exponents. Always pay attention to just how many digits you have. Okay, let's look at multiplying and dividing when we have significant figures and how that impacts the answer. So the big thing to remember here is that when you multiply and divide values, you round the answer to the least number of sig figs from the numbers you started with. So in this case, these both have 4 significant figures. So 304.7 has 4 sig figs, and 800.0 has 4 sig figs. So that means that whenever we do this multiplication, then we want to keep the first 4 digits. I looked at the 7, and to determine whether to keep it 7 or round it up, I had to look back at the 6th. And since the 6 is larger than 5, then that means I'm going to round the 7 up to 8. So that's how I end up with a sig figs answer from this multiplication of 243,800. Both of these values had 4 significant figures to start with. So our answer has 4 significant figures. Now, what happens if we have a situation where we have 4 significant figures in one value and only 1 significant figure in this second value? So this 800 has now changed, so we only have 1 sig fig. So in that case, we only look at the number 2 and decide whether or not to leave it alone by looking back at 4. 4 is not large enough. If this was a 5 or larger, we would round 2 up to 3, but it's not large enough, so we simply leave this as 200,000. So the significant figure answer for multiplying these two values is simply 200,000, because we can't be confident about all of this stuff on the other end of the number. Notice there's no decimal point on here, because this also tells us that we're only sure to 1 significant figure in this answer. Always whenever you're using significant figures in the context of a problem, you don't apply the significant figure rules until you get to the very end of the problem. So I'm showing you these on individual calculations, but you would not apply sig fig rules in the middle of a problem if you had multiple calculations to make. You would only apply that sig fig rule at the end. Now let's look back at the problem we looked at before, where these are both 800. However, this is 800 with 1 sig fig, and this is 800 with 4 sig figs, and it really impacts the decision, the answer quite a bit. It was the same, generally the same numbers in the multiplication, but the significant figures really impact the reported final value. Okay, one more. Let's look at this one. So this is with a number that's in scientific notation. So 9.02 times 10 to the third, if we expand that out, then that means that we're going to move that decimal point over 3 places, and we get 9,200 divided by 81, and we get this 113.5802469. Well, that's a lot of mess. Most of this over in here has no value at all. So let's look and figure out what we do want to keep, what we can keep from a significant figure perspective. This value has 3 sig figs. This one has only 2. So we always keep the least number of sig figs in our answer, so our answer needs to be rounded to only 2 significant figures. So if we look at this, we're going to keep these first 2 digits, the 1 and the 1. Look at this 3 and decide whether or not the 1 stays the same here or gets rounded up. It's not large enough to round it up. This would have to be a 5 or larger, so that means that our significant figure answer for this calculation is 110. Okay, this is a key for the examples on the back of the note. So if you weren't sure how many sig figs all those values had, I've provided that for you here. So you can stop this if you'd like and take a look through this and see whether or not you've interpreted that back page correctly. And be sure and go do that homework that you were prompted to do before using those Kia flashcards.